Alright, here we're going to learn about compound probability. So last year you learned about simple probability, which means one event is going to happen. Compound probability means that more than one event is going to happen. Probability, in general, is just the likelihood that an event will occur. We're always going to write that as a simplified ratio, which really just means a fraction, a simplified fraction. Probability of an event is always in between 0 and 1. 0 means it's impossible. 1 means that it is certain that it will happen. Our notation for writing probability is written like this: P of some event that we want to have happen. And to find that, we're always going to think about the number of favorable outcomes divided by all the possible outcomes. When I say favorable, that might make it sound like it's a good or bad thing. It's not really. It's really just talking about this event. How many chances are there for that thing to happen out of all the possible combinations of things that could happen? Alright, so looking at that spinner. The number of possible outcomes, it's really just how many sections we have on the spinner. There are 8 sections, so there's 8 possible outcomes. The probability of spinning an odd number, we're going to write that as P of odd. So we want to think about how many odd numbers we have on that spinner. 1, 3, 5, 7 are all odd. That's 4 out of 8. It's 4 odd numbers out of the total of 8 numbers altogether. If you can simplify, you always want to simplify. So we could divide by 2 on top and on bottom. That's going to take 2 steps. We would divide by 2 and then divide by 2 again. Just doing it in one step, we could just divide by 4 on top and bottom. And that would give us 1/2 as our probability. And that should make sense. Half of these numbers are odd. On the second one, we're looking to get either an even or a 7. So the probability that we get an even number, that would be 1, 2, 3, there's 4 even numbers, or a 7. That means we're okay with either of these two, so we're going to include 7 there. So that means there are 5 favorable outcomes. That's describing 5 options out of the total of 8 options. That one doesn't simplify, so that's going to be our final answer. In the second example, we have a bag of blue marbles, red marbles, and green marbles. Marble is selected at random. First, we always need to think about all the possible outcomes. So we could get any of these marbles. We're really just going to add these together. 7 plus 5 is 12, plus 8 is 20. So there's 20 possible outcomes when we pick out a marble. 7 of those are green. So the probability that we get a green is 7 out of 20. The probability that we get a yellow, well, there's blue, red, and green ones. There are no yellow ones, so that is 0 out of 20. There's no chance that we get a yellow one. Probability that we get something that's not red, that means the blue ones or the green ones. So we're going to put those two combinations, or 2 options together. That's 12 out of 20. That one we can definitely simplify. Those are both even numbers. So we could divide by 2. There's a bigger number that we could also divide by. We're going to divide by 4 on top and bottom. Simplifying sometimes is about just guessing and checking and seeing if a number divides the top and the bottom. You have to divide by the same number on top and bottom, and it's got to divide them evenly. This has to turn into a whole number. Here it does. It's 3. And this also has to be a whole number. Here, that's 5. So 3/5 or a 3 out of 5 chance for getting something that's not red. All right, all of that was just dealing with one event. The chance that we get a green, the chance that we get yellow. Even this, when we say an even or a 7, we're only spinning the spinner one time. We just have one fraction. Compound probability is dealing with 2 events. So these 2 events are either going to be dependent or independent. Independent means they do not influence each other. So one event does not have any effect on the second event. So either the events are completely unrelated, or you're going to think about this idea: events that occur with replacement. Now, it doesn't need to be phrased like that, but the idea of replacing whatever you did the first time means we're making that second event independent of the first one. It's going to make more sense when we talk about examples, but if you see that idea, replacing whatever you took out the first time, it means we're resetting. So like for this bag of marbles that we had, if we take out a blue one and we replace it, we're restarting that bag with 20. But dependent events means we're going to take out that blue one and not put it back in, and we're going to change the bag going into the second event. So dependent events are events that do influence each other when we do this without replacement. If you take out a Jolly Rancher, you eat it, and now you take out another Jolly Rancher. When you pick out that second one, the chance that you pick out another blue one is now different because you've eaten the first one. You've changed the bag going into the second event. So we're going to decide on each of these if they're independent or dependent. Not sure why this is lagging. I don't know what's going on anymore. All right, rolling a number cube and flipping a coin. A number cube is the SOL's way of saying rolling a die or a dice. So we roll a die, you flip a coin. Those are completely unrelated. If we get a 6 on the die, it doesn't somehow change the chance that we get a heads on the coin. They do not impact each other. They're independent of each other. If we pick out a marble from a bag and we give it to a friend, then we pick out a second marble. By giving that first marble to a friend, we're changing the bag. The second marble that we pick out, the probability of getting that second marble is now different because we changed the bag by giving out that first marble. Those are dependent events. Whatever happened in the first event changes what happens in the second event. Picking a Jolly Rancher from a bag, eating it, and then picking another Jolly Rancher. By eating that first Jolly Rancher, the probability of getting, let's say, a blue Jolly Rancher in the second one is now different. So by not replacing it, we're changing the probability of the second event, so the second event is dependent on the first one. Pick out a Jolly Rancher from a bag, put it back because you don't like that flavor, and then pick another one. By putting it back in, we're resetting the bag. So that means the second one is not influenced by the first one. Let's say we got a blue one in the first one. We have the exact same probability of getting a blue one here because we put that first blue one back in. Those are independent of each other. All right. So you have 2 questions directly on your test just asking about that vocab, whether you know if it's an independent or a dependent event. The rest of those problems are going to be problem solving. So the way we find the probability of compound events is by multiplying the 2 probabilities together. So if I want to know the probability of A and B happening, 2 different things happen, that word and is important, then we're going to multiply those 2 probabilities together. You find the probability of A times the probability of B. So you're really just splitting it into 2 fractions and then multiplying those 2 together. So Miss Cotillo loves movies and can't decide which 2 movies to watch tonight. She puts 4 fantasy DVDs, 3 drama DVDs, and 5 comedy DVDs in a bag. What's the probability that Miss Cotillo picks out a drama, she replaces it, and then picks out a comedy? So first off, I just want to decide, are these independent or dependent? By replacing the first one, we're resetting the bag of these 12 DVDs. We started with 12. We took out a drama. We put it right back in. We still have 12. Those are independent events. Doesn't really matter what happened in the first place because we replaced that first one, and now it's reset as we're trying to pick out a comedy. So we're going to find the probability of getting a drama times the probability of a comedy. The chance that we get a drama is 3 out of the total. 3 plus 5 is 8, plus 4, like I said before, that's 12, so it's 3 out of 12. Times the chance that we get a comedy. We took out a drama, we put it right back in. We still have all 3 of these, so we still have 12 altogether. And we still have all of our 5 comedies. So we're going to multiply these together. When you multiply fractions, you multiply straight across. But before we do that, we're going to simplify this fraction. You could simplify at the end, but then you're going to be dealing with bigger numbers. So I would simplify here, and then just deal with smaller numbers at the last step. So 3 and 12, we want to think about what's going to divide 3 and 12 both evenly. Well, 3 could divide 3, and 12 That's going to change into 1/4. And 5/12 does not simplify, so we're just going to multiply those together. We do not have an equal sign in here. We're not cross multiplying. You're multiplying straight across. 1 times 5 is 5. 4 times 12 is 48. So the chance that happens is 5 out of 48. That's a pretty low probability. Ms. Kamiyama wants to pick out a few pieces of candy out of a jar. There are various pieces including 5 strawberry, 4 orange, 3 grape, 3 watermelon. What's the probability that Ms. Kamiyama picks out a strawberry, eats it, and then chooses a grape? By eating the strawberry one, we're changing the chance that we can get a grape. The probability for that second event depends on the first event. Whatever happens here is changing the second event, so these are dependent events. So we're looking at the probability of getting a strawberry times probability of getting a grape. So we start out with all 5 of these. That number is not changed. When we're first picking one out, it's 5 out of, that's 15 altogether. Times the chance that we get a grape. We still have all 3 of these grapes, but the strawberries are now different. We just ate one of these strawberries, so instead of having 5, now we're down to 4. So we have 4 plus 4 plus 3 plus 3. That is 14. So we're losing one of these pieces of candy because we just ate one. So it's going from 15 down to 14. We still have all 3 grape. That number is not going to change. Again, I want to simplify these first. I see that this is a 5, that ends in a 5, so I can divide by 5 on top and bottom. That would give me 1/3 times, that doesn't simplify, 3/14. Again, we're going to multiply straight across. 1 times 3, that's 3. 3 times 14, that is 42. It might not be immediately apparent that that can be simplified, but I noticed that there's a 3 on top and a 3 on the bottom. We multiplied by 3 here, and we multiplied by 3 there. That means we could divide by 3 on both top and bottom. We're going to divide by 3 there, that'll give us 1. Divide by 3 here, it's going to be back to that 14. So again, I want you to notice the difference between these two. Here, we replaced the DVD, so it stayed as 12. Here, we ate the piece of candy, so it went down to 14. It's only ever going to go down by 1. That's all that's ever going to happen. Sometimes the number on top is different, but this bottom number, if we eat or don't replace, or we take that out and somehow it doesn't make it back into the bag, that's going to go down by 1. Example 3, one letter is selected from the pile, and the spinner is going to be spun. What's the probability that both letters are not vowels? So we're looking to get something that's not a vowel here. Well, A and E are the only vowels there, so we have 1, 2, 3, 4, 5 that are not vowels. So the probability that we get not a vowel in the pile of letters is 5 out of 7. Times the probability that we get not a vowel on the spinner. It's kind of the same. A and E are the 2 vowels. 1, 2, 3, 4 out of 6 sections. We could simplify this, but actually looking at how I'm going to put my answer on this number line, I don't really care. I'm going to end up changing this into a decimal anyway. So I don't need a simplified fraction. I'm just going to multiply these straight across. 5 times 4 is 20. 6 times 7 is 42. So you could just divide that and figure that out as a decimal, but I'm just going to estimate 20 out of 42, well, 21 out of 42. That's exactly half. So I know that would be at 0.5. That's just a little bit less. So 20 out of 42 is just to the left of 0.5 there. Again, if you want to simplify that, you could. 10 out of 21 is the exact same thing, just a little bit less than half. All right, last example. We have these 12 cards with different patterns on them. What's the probability that we reach in, get one that has stripes, we keep it, and then get one that isn't shaded? All right, so the probability that we get one that has stripes times the probability that we get one that isn't shaded. So So, chance that we get a stripes, 1, 2, 3, 4 out of 12. Chance that we get one with stripes is 4 out of 12. We're keeping that first one. So we're going to get rid of one of these, and we're keeping it out of the deck. It doesn't really matter which one, but I like crossing this out just to show how many we have left now. So the chance that we get one that isn't shaded, these 3 are shaded. So the ones that aren't shaded are 1, 2, 3, 4, 5, 6, 7, 8. There's 8 that are not shaded out of the 11 remaining cards. We had 12. We got rid of that one. Now we're down to 11. We kept that first one. That's the important thing. That's why this number is dropping. So again, we're going to simplify. We could divide the top and the bottom by 4. That gives us 1/3 times 8 over 11. And now we can multiply straight across. 1 times 8 is 8. 3 times 11 is 33. Last one. I think this phrasing confuses people sometimes. You pick 2 cards without replacement. It's not saying we do that before the problem starts. It's just announcing what we're about to do. It's saying you're about to pick out 2 cards and you're not replacing the first one. What's the probability of getting an even number and then another even number? So probability of an even times probability of an even. So chance that we get an even, 1, 2, 3, 4, 5, 6. There's 6 out of 12. 6 out of 12. It's just half. And you should be able to see that half of these numbers are odd. So probability that we get an even number is 1 out of 2. We're doing this without replacement. We're not putting that one back in. It doesn't matter which one. I'm going to pick that one to remove. That doesn't go back in the deck. Now I'm thinking about the chance that I get an even one. So 1, 2, 3, 4, 5 even ones left. There were 6. Now we're down to 5. And we started out with 11. We started out with 12. And now we're down to 11. We just got rid of one. So we have 11 left. Now I can multiply straight across. 5 times 1 is 5. 2 times 11 is 22. All right, that is compound probability. Hope this helps.